Example discrete distributions, the hypergeometric distribution. While this distribution is not explicitly on the syllabus, it does say that we should look at examples of non-uniform discrete distributions, and the hypergeometric is one such. So we'll have a brief look at the hypergeometric distribution. So we're going to be looking at this with regard to a box that contains some yellow and red disks, and we use this also in one of the examples that follows. The box contains two types of object. Let us define taking a yellow disk to be a success and taking a red disk to be a failure. The box contains the population of objects, in this case of size 30. There's 30 disks in here. And from this population we draw a sample. The random variable x is the number of successes in the sample. In other words, we take some out, and the number of yellow disks, since we've defined that to be a success, will be the value of x. In this case, the population contains 9 successes and hence 21 failures, because we know there's 30 in total. Suppose we take a sample of size 5. We're going to do that in the example as well. X could clearly take the values 0, 1, 2, 3, 4 and 5. We can work out the probability for each case. So what we're saying here is it's possible to get 0 yellow disks and any of the other numbers up to 5. Suppose we take a sample of size 12. X can take the values 0 to 9. It can't take the values 10, 11 and 12. As there are only 9 successes in the box. If you count the yellow disks, there are only 9 of them. We could look at this as x being able to take the values 0, 1, 2, 3, 4, 5, 6 and up to 12, with probability of x is 10, 11 and 12 as being 0. It's just another way of looking at it. In general, we only look at the case where the sample is less than or equal to the number of successes. In other words, not the second situation we just looked at then. In general, the population is of size big N. There are k successes in the population and hence n minus k failures. And we take a sample of size little n. There are kcx, that's k choose x, an alternative notation is this, ways of choosing x successes from the k successes that are in the box. Think about this. Our sample contains x successes chosen from the k successes in the population. There are n minus k c n minus x, or we could write that like this, ways of choosing n minus x failures from the n minus k failures that are in the box. Think about this. Our sample size is n, so if we have x successes, we must have n minus x failures. These will be chosen from the n minus k failures. Remember, the population of the entire box is n. We have k successes, so we must have n minus k failures. Our sample will contain x successes and n minus x failures. So the number of ways we could choose such a sample is to multiply them together. This is the number of ways we can get x successes from the k successes we have. This is the number of ways of getting n minus x failures from the n minus k failures we have. Multiply them together and we've got the total number of ways that we could get x successes and n minus x failures. Overall, the number of ways of choosing a sample of size n from a population of size capital N is nn. So therefore, the probability of x being x is the number of ways that x can be x, as discussed here, divided by the total number of ways, and we know that x is both less than or equal to n and less than or equal to k.